Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Guys, today we will go through the core concepts related to the engineering, or we can say that the remote sensing platforms, classifications of orbits and its relationship. Here, the sensor, the platform are related with reference to the eye and the body. With reference to that eye in the body, we have to check or we have to collect the data. Now the remote sensing platforms, they are nothing but the vehicles or the structures used to carry sensors for acquiring information or data about the earth surface, just like these two figures. Here the platform is the vehicle or carrier for remote sensing sensors. With reference to that core definition, the sensors records the data with reference to the platform, and that determines the position, which is based on altitude and location and the orientation of it. So the platforms provide suitable height, stability and coverage for collecting spatial data that will be required for engineering investigations. So here these remote sensing platforms are broadly classified into ground based platforms, airborne platform and spaceborne platforms according to their operational altitude or height from the earth surface. So the platform selection depends on project scale, requirement solution, objective and frequency of data acquisition. So the engineering insights related to that platform, which are specific sensors that require specific platform, which are based on mission or objective requirement like coverage area and revisit frequency. See the overview, that is the altitude hierarchy. With reference to that, 0, that is the earth surface. After that 50 kilometer, then 150 kilometer and 36,000 kilometer. So here up to 50 kilometer, the ground based platform is in picture. Up to 150 kilometer from the earth surface, airborne platform, which is of 50 meter to 50 kilometer range. And then the 36,000 kilometer, that will be the space bomb, which is more than 150 kilometer from the earth surface. Likewise, we check or we see the mode of data collection, just like aircrafts, satellites, they are in the spaceborne platform. Then drones, balloons, small aircrafts are for in the airborne platform, where the ladder, then platform vehicle which is utilizing for lifting the crane like structure or transmission towers in the ground based platforms. So they each and every platform have their defined function, and with reference to their altitude point of view also, or the stationary geostationary, stationary or sun synchronous or orbit point of view also, we can check their hierarchy and study. Then first, ground based platform. So here in the ground based platform, we carried the calibration and ground truthing, or we correct the data. Ground platforms include towers, tripods, cranes, vehicles and terrestrial laser scanners that position close to the earth's surface or the ground control points, so that they provide highly detailed data and precise measurements over small area also. So the ground based system are extensively used for calibration, validation and geotechnical investigation point of view. So civil engineer use that method to check the deformation monitoring, bridge inspection, pavement evaluation and slope stability assessment. Next one will be the airborne platforms, just like the aircraft's point of view. With reference to aircraft, the image capturing cameras are attached with reference to the whisk broom technique, and that cameras emitting the rays with reference to the instantaneous field of view, and they cover the swath on the earth's surface. So we can check the flexibility and the high resolution with reference to the airborne platforms for the data collection point of view. The vehicles use with reference to the fixed wing aircraft that are stable and long range. With reference to the helicopters also, they have their defined path, that is we can say that the flight path for it. These are the scan lines across the track. This is the actual swath area on the Earth's surface. This is the instantaneous field of view. So the advantages of the airborne platforms related to the flexibility, maintenance and resolutions point of view, where airborne platforms consist of aircraft, helicopters, unmanned aerial vehicles and balloons like structures to carry the remote sensing sensors. They operate at relatively low altitude and provide high spatial resolution imagery as a data collection point of view. See the balloon platform, from the historical origins to the stratospheric science we are using in vintage eras. With reference to the balloon, in 1858 the first aerial photography by the Nadar is taken, and then modern engineering point of view we see the operating altitude for that balloon like 20 to 30 kilometers. There are two types of balloons, free floating balloons and tethered balloons. With reference to that we collect the data and we use it. So airborne observations are particularly useful for site specification, investigation and engineering survey point of view. So here the primary applications of the balloon platforms with reference to the meteorological point of view, wind probing and sensor testing prior to the space launching. Then next one will be the unmanned air vehicle or the drone platforms. These are all the modern civil engineering standards. With reference to that, civil engineers can use that airborne systems for corridor mapping, urban planning, construction monitoring and flood assessment also. There are two types of unmanned aerial vehicle, that is fixed wing and then vertical takeoff unmanned aerial vehicles, just like the helicopters or just like the small drones. So the civil engineering point of view we see that we can use that fixed wing unmanned aerial vehicle with the high altitude for the long endurance, for example wildfire monitoring. But for the rotary or vertical takeoff point of view we see the, with reference to that we check the suitability or accessibility for the purpose with the bridge inspection and precision mapping point of view. So here that civil engineering applications where the infrastructure monitoring for stress management or the stress or the loading action or any geological or geotechnical point of view we check the soil or rock type of cracks, landslide assessment and hazardous area survey monitoring. Second type, that is the spaceborne platforms. There, that is a global view which is more than 150 kilometer away from the earth's surface, where the sensors operate outside the atmosphere. No maintenance access will be there. So the spaceborne platforms are the satellite placed in the specific orbits around the earth's surface with the continuous and repetitive data collection method. They provide synoptic coverage, long-term monitoring capability and access to inaccessible region. Here the advantages are the global point of view, repetitive coverage point of view and cost efficiency point of view, with the classification of earth resource satellite, meteorological satellite and microwave sensing satellite. So satellite observations support regional and global studies with standardized data sets, so that civil engineers use that for watershed management, land use mapping, infrastructural monitoring and disaster management on the earth's surface. Next one will be the orbit classification. So here the classification orbit based on some altitude point of view. We check that altitude 160 km to 2000 km low earth orbit, near about up to 20,000 km medium earth orbit from 2000 to 20,000, then from 21,000 to 36,000 which will be the geostationary orbit. Hence the satellite orbits are mainly classified into three parts. That orbital characteristics determine revisit frequency, image resolution and coverage area, where that selection of particular orbit depends on its objective and sensor requirements. So orbit characteristics comparison point of view we check that low earth orbit for high spatial resolution but which covers smaller area, then medium earth orbit which provide wide range or wide coverage suitable for navigation and positioning application point of view, but the geostationary orbit which provide continuous observation over large region, they generally have lower spatial resolutions. So if we have high resolution we can prefer low earth orbit, or if we want to cover large area then we can prefer geostationary orbits. So here the low Earth orbit satellites generally operate with reference to the altitude, just like the example of Landsat and Spot. These satellites provide high spatial resolution and frequent observation suitable for Earth resource data or study. Next one will be the medium Earth orbit. These satellites are primarily used for navigation and positioning services, just like the GPS, GLONASS, Galileo, Navic within the medium Earth orbit, and the polar orbits or the geostationary orbits. These orbits are up to the altitude of 36,000 km. They collect the data of the weather or meteorological data or the common surveying data analysis. Next one, that is the geostationary satellites, which is a fixed point observation, which is based on the mechanism of satellite rotates within the earth, appearing fixed over the equator. So here that will be satellite. This is the actual revolving path of that satellite. So orbital period is of 24 hours, which matches earth rotation. This is the actual altitude near about 36,000 km from the earth's surface. This is the actual instantaneous field of view which covers whole earth or mother earth. So geostationary satellite orbit it approximately up to the 36,000 km altitude with one revolution in 24 hours. They remain fixed relative to the particular location on the earth's surface with reference to the nadir point below to that satellite. That geostationary satellites provide continuous monitoring of weather system and atmospheric conditions, so that the civil engineering applications or civil engineers use it for flood forecasting, cyclone monitoring, and disaster preparedness point of view. The examples of geostationary satellites are GEOS for USA, Meteosat for Europe, and INSAT for India. Next one will be the Sun-Synchronous orbit or the polar orbit, which is a consistent illumination of for the earth resources, where the mechanism of that Sun-Synchronous polar orbit related to the 700 to 900 kilometer altitude that shifts to keep pace with the sun rays. So here the sun synchronous satellites are a special type of polar orbit satellites that cross the equator at the same local solar time, that ensures that uniform illumination condition and which improves comparison between images acquired on the different dates. So the most earth observation satellites operate in sun synchronous orbit at altitudes of approximately 600 to 900 kilometer, and the civil engineering domain that used for the change detection and urban growth analysis point of view. Here the comparative part for the major earth resource series, that major earth resource series are related to the country based data or satellite, where the USA Landsat, Indian remote sensing IRS, where France that is a spot. So here the status for each and every system or resource series explains that the longest continuous record since 1972 by the USA. For India, Indian remote sensing series, this is the actual status, where spot will be the system for observation dilatory, which is the France spot system. Now the sensors used in the Landsat USA longest continuous record, that is Landsat thematic mapper and MSS, that type of sensors are used, where in India LISAS, that is linear imaging self scanning point of sensor is used for data collection point of view, and in the spot owned by the France, where pioneered push broom scanning or feature is used for data point of view. So here the resolutions point of view, we see the moderate resolutions for USA near about 30 meter. In Indian point of view, we take the focus of national development, agriculture and water resource point of view as objective to collect the data or to motivate the departments of government to take that initiative to collect the data or to analyze the data. Owing towards the France point of view or spot, that is the capability of off-nadir viewing for stereo 3D capabilities. Here the platform selection criteria, that is the engineer's decision matrix, which is based on the four conditions: spatial resolution, coverage area, budget and timing, or that is urgency. Here no signal, no single platform is perfect. The choice depends on the scale and constraints of the project. Means the objective we decided for any type of usage of platform. So selection of a remote sensing platform depends on project area, requirement of resolution, revisit frequency and the budget allocated. The ground platform provide detailed location information, whereas satellites are more suitable for regional assessment or analysis point of view. So unmanned aerial vehicles and airborne platforms that bridge the gap between field surveys and satellite observations, where the proper platform selection enhances the efficiency and reliability of civil engineering investigations. So the application point of view with reference to the civil engineering domain, that satellite imagery supports transportation planning, watershed management, where the global navigational satellite system GNSS satellites enable precise surveying and positioning for engineering construction projects, where the airborne and unmanned aerial vehicle platforms provide high resolution data for site investigation and project monitoring purposes. The combining use of different platforms that are ground based, airborne or spaceborne, that improves decision making process, comparatively utilization or by simultaneously cross checking the data. For the resource management point of view and sustainability of infrastructural planning, we prefer the platform selection or the n number of platforms or selection criteria for our feasibility purposes. Stay tuned guys. Happy learning.